Yes. So in the last class, right, what is big data? Why Hadoop? Drawbacks with the current databases? Hadoop advantages? Hadoop and PySpark job market, right? Yes. This is what I discussed in the last class, right? Yes. Mhm. So Hadoop provides two types of services, storage and processing. Hadoop provides two types of services, storage. For storage, we are using HDFS, and for processing, MapReduce or Spark. It doesn't use any database for storing its data. It's going with a file system called Hadoop Distributed File System. And for processing, we are going with the MapReduce or Spark. Hadoop is not for online applications. It's for batch applications, right? Hadoop is meant for batch applications. There are two types of applications. There are two types of applications. User interactive applications. Okay. Online applications and batch applications. There are two types. Hadoop is for batch applications, right? So there are two types of applications, online applications and batch applications. Online applications, user interactive applications, user interactive applications, right? Yes. Here user gives the input. User gives the input. Booking a movie ticket, making online payment. But Hadoop is not for online applications. It's for batch applications. User non-interactive applications. Here user is nowhere required. User is nowhere required. Railway ticketing, PNR status. Railway ticketing, PNR status. Generating credit card statements for millions of customers. Generating credit card statements for millions of customers means here uh, railway ticketing PNR status means currently your waiting status is 200. After 1 hour it is 150. Tomorrow morning it is 100. Tomorrow evening it got confirmed. Here user has nothing to do. It happens in the background. Most of these financial applications, banking applications or batch applications, right? Yes. Here user is nowhere required. Railway ticketing PNR status, credit card bill statements for millions of customers. So yesterday I was discussing about the drawbacks with the current databases. A limited storage in GBs or in TBs, no parallel processing in most of the databases. If volume increases, speed decreases. Right? If volume increasing, speed decreases. Means if you see query to query, as the volume is increasing, speed decreases. Total amount from sales 1, total amount from sales 2, total amount from sales 3. Query to query, volume increasing, speed decreasing, right? Even if complexity increases, speed decreases here. Total sum of amount from salesman, average amount from salesman, standard deviation of amount from salesman. Query to query, if you observe here, this average amount is a two-step process. First sum to be calculated, next average to be calculated. As compared to the first query, this is going to take a lot of time. And this third one take a lot of internal processing. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Hadoop doesn't follow. See here, before I go with the Hadoop advantages, you need to know something about the Hadoop architecture. Hadoop doesn't follow client-server architecture. It won't follow client-server architecture. It follows master-slave architecture. Hadoop follows master-slave architecture. Group of nodes, CPUs connected in a network, right? Hadoop cluster, right? What do you mean? Okay. Hadoop follows master-slave architecture. Observe this. Single master and multiple slaves. Single master and multiple slaves. It's not like client server. It is like master slave. Single master and multiple slaves. S1, S2, so on, SN. Single, this entire thing, group of nodes, group of CPUs connected in a network. Group of nodes, group of CPUs connected in a network. This we'll call it as a cluster. This we call it like master node. Within the master node, we have got a name node. Name node, we say. So these are slave nodes. These are slave nodes. Slave nodes are, in Hadoop terminology, we call it like the data nodes. Slave nodes are data nodes. Data is stored by the slaves. Data is processed by the slaves. Data stored by the slaves. Data processed by the slaves. If data is stored by the slaves and data processed by the slaves, what master node is going to perform? Master node assigns tasks to the slaves. T1 task, T2 task, T3 task. F1.txt. In F1.txt, divided into, in Hadoop, file, assume 2 TB file. Assume each system hardware capacity 1 TB, hard disk capacity 1 TB, 1 TB. This file cannot fit into any of these slaves. This file cannot be fit into any of these slaves. This 2 TB cannot be accommodated by any of these systems. So in Hadoop, always the files are divided into blocks. Files are divided into blocks. The blocks are distributed across multiple slaves. This one into multiple distributed across multiple slaves. and are processed parallelly. These are distributed across multiple slaves and are processed parallelly. So the two advantages we can see here. Distributed storage here, distributed storage and parallel processing. What are the things? Distributed storage and parallel processing. Okay. Master node responsibilities. Master node responsibilities means task assignment, load balancing, task assignment, load balancing means whatever the task assigned to the slave should be equally assigned to all the slaves. Fault tolerance means if multiple tasks are executed by multiple slaves, these multiple tasks are executed by multiple slaves. Suddenly, if one system is down, suddenly if any system is down, right? Suddenly if any system is down, then the task of it, then the task of it, the T2 task of it will be assigned to any of the other slaves. This process is called fault tolerance. If multiple tasks executed by multiple systems, suddenly any one system is down, then the task of it will be assigned to any of the other slave. This process is called fault tolerance. Health monitoring. Before assigning tasks to any of the system, right? So masternode has that. Masternode has the entire knowledge of all the slaves. Then their health status. It has got the entire health status of each and every slave, right? And slave node responsibilities I discussed, storing the data, processing the data, right? Storing and processing the data. Okay, yesterday I was discussing about Hadoop advantages, right? Unlimited data storage is possible in Hadoop because of a feature, horizontally unlimited scalability. Horizontally unlimited scalability means horizontally unlimited scalability. Today, if you are running a business with a very less number of slaves, running a business with very less number of slaves, S1, S2, so on, S3. Okay, fine. So if I'm running, if you've got a very small cluster with a less number of slaves, for example, your data is increasing, means your customers have increased, your branches have increased, then your data also will be increasing. You should also increase the customers. Sorry, this systems also. When your data is increased, right? Your number, the systems also has to be increased. If data increased by 100 times, if customers increased by 1,000 times, right? Then you cannot go with the same number of systems horizontally. Any number of unlimited number of systems can be added. The data is getting distributed across all these systems. That's why unlimited data storage is possible, right? Yes. Okay, fine. Very high speed processing because of parallel processing, as data is distributed across multiple systems running parallelly, right? Parallel processing we are going to observe can handle all varieties of data, structured, semi-structured, and unstructured, right? It is an open source, no licensing required. Most of these Hadoop products are from Apache, right? Apache Software Foundation, from the Apache mirrors, right? You can get it. Commodity hardware. Commodity hardware, right? So it doesn't mean that you need to have highly configured systems. You can run this Hadoop in any hardware, right? Doesn't require that latest configurations. Yes. So main advantages of Hadoop: unlimited data storage and very high speed processing. Why databases like Oracle won't support unlimited storage? Why only Hadoop is able to store from data? Why databases like Oracle won't support unlimited storage? Okay. Even for databases like the databases, the real time we have got, can go with multiple number of slaves, databases, and the max limit on the number of nodes. Max limit on the number of nodes. For Oracle, maximum which go with 256 nodes are CPUs. For MySQL, you can go with the maximum 54 CPUs or nodes, right? For MySQL Express, you can go with the 256 nodes. Even for SQL Server, we can go with 256 nodes, sir. Even for DB2. For Teradata, it's a kind of data warehouse kind database used for specialized database used for data warehouse purpose. Can go with 512. Netija also can go with 512. Vertica. These three are for data warehouse purpose, right? Databases used for data warehouse purpose. Okay, but currently Teradata and Netija are supporting 1024 nodes. They are supporting 1024 nodes, right? So even though 256 or 512 or 1024, once they get filled, they cannot support data further. But there is no limit on the number of nodes that Hadoop can have, right? There is no limit on the number of nodes that Hadoop can have. There is no limit on the number of nodes that Hadoop can have. Unlimited number of nodes. Means keep on adding, right? When Yahoo first time implemented Hadoop, it went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. When Facebook first time implemented Hadoop, went with 8,000 nodes. Currently, Facebook going with 42,000 nodes, right? It's going with 42,000 nodes for storing its data. This is what Hadoop is proven storage point of view. Not like a 512 unlimited number of nodes, like thousands of nodes, 10,000 or 12,000 or 42,000 or 50,000 nodes, right? There is no limit for the number of nodes that Hadoop can have, right? Yes. As I was discussing, right? Even processing point of view, right? Hadoop has got high speed. So as Yahoo has conducted a test by taking a table of 100 TV consisting of 1024 columns, task sorting based on 16 columns, time taken by different databases, right? Oracle has taken nearly 3.5 days to process. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours. Hadoop has taken 3.4 minutes. And latest version of Hadoop has just taken 1.2 minutes. Okay, fine. So Hadoop is proven in the market, processing point of view, storage point of view, right? Yes. Okay. Very high speed processing, right? 1 second. So Hadoop is proven in the market, right? It is proven in the market. Storage point of view, processing point of view, right? Just before I discussed storage point of view with unlimited data storage and processing point of view, right? Very high rate of speed. So as part of this, okay, yesterday I was discussing about Spark also, right? Very high speed processing technology with in-memory computation. So it lighting speed technology for fast computation with in-memory computation, distributed execution with parallel processing. Right, I can say even Hadoop has taken 1.2 minutes. So observe here, Oracle, MySQL, Teradata has taken 3.5 days, 6 days. Teradata and Netija has taken hours. Hadoop has taken minutes. Hadoop, you are thinking Hadoop speed is this much. But if you talk about the Spark speed, 100 times faster than Hadoop, then see the speed of Spark. Spark is 100 times faster than Hadoop. That's why very high because of in-memory computation, loading and processing both happening at this memory level. That is RAM level. That's why very high speed. Okay. So as part of this course, right, the Hadoop ecosystem components, what I'm going to discuss. HDFS for storage, MapReduce for processing, Apache Hive is also meant for processing. It is a kind of data warehouse kind of environment. Data warehouse kind of environment, right? Yes. Yes. HQL, it has got HQL Hive query language similar to SQL. HQL, which is similar to SQL, right? Yes. One more component like scoop. Scoop is first two characters from SQL, last three characters from Hadoop. Forms a scoop for importing or exporting data. For importing from databases to Hadoop, exporting from Hadoop to databases. And NoSQL databases, right? Schemaless behavior for random access. I'm discussing one NoSQL database like HBase. Yarn, yet another resource negotiator, yet another resource negotiator. Zookeeper, control and coordinates all the Hadoop components. Flume Kafka for capturing live streaming data. This streaming data, I'll be giving knowledge on this Flume and Kafka, right? Streaming data which keeps on incrementing, the data which keeps on generating, data which keeps on generating, which keeps on incrementing. Such data we call like live streaming data, capturing that, storing in Hadoop environment and processing it very the rate at which the events or data is generated at the same speed, the data has to be processed and providing the quick results or updates, right? That's why very PySpark has got very high speed, right? PySpark has got very high speed processing. Here also like Spark Core, Spark SQL, and Spark ML, right? Yes. This is what I'll be discussing: Spark Core programming, Spark SQL, and Spark ML, right? Yes. Okay, fine. How exactly? Okay, Spark Core, Spark SQL, Spark ML. Fine. Understood, right? So Hadoop and Spark both combinedly used in today's, right? You can just check a lot of jobs. You can just observe this PySpark jobs or Hadoop jobs. Hadoop and PySpark both combinedly used today for storing and processing, right? Yes. Okay. Understood, right? Hadoop and Spark, very high speed and unlimited data storage, both is available with this. Fine.
Sorry to interrupt, sir. I have one quick question. The Kafka thing which you said, right? So do we need to have experience or you teach Kafka as well? I mean that like the basic stuff to understand the Kafka thing.
I didn't get your query. You want?
About the Kafka which you mentioned the
Yes,
syllabus, right?
yes,
So I have not worked on Kafka. So is it something that I will get to know something in this session
yes, yes,
during
yes,
the
yes, yes. So as part of this course, right, I'm going to provide you the knowledge on this, nearly like one storage component, one
okay.
storage component, like processing components. MapReduce, Hive, Spark. Three processing components like MapReduce, Hive, and Spark. One NoSQL database will be provided,
Mhm.
HBase, and the streaming technologies, right? Bloom Kafka, but Kafka mostly used. You'll be getting the knowledge of all this, right?
Okay.
So storage, one storage, three processing technologies, one NoSQL. Because today, NoSQL is mostly used than SQL. Talk about the top e-commerce websites, all they are using NoSQL today because of schema-less, because this SQL requires a schema, a record to record, the same number of fields to be maintained in case of SQL, but in NoSQL, record to record, different number of fields can be maintained. My first record with 3 fields, second record with 5 fields, third record with 10 fields. For example, if we take example of Amazon, books having 4 fields, electronics having 6 fields. For example, home appliances having 7 fields. So you can all store in one kind of table, NoSQL table. But in case of SQL, right? They need to have the same number of columns. Every time we need to alter, otherwise if you want to modify it.
Sure, sir. Yeah. Thank you.
Okay. So as I said, right? So just we can observe this course content also in brief, in depth, we'll be discussing about it. This is the course content. Hadoop. What is Hadoop? Challenges with Hadoop. HDFS in brief. Hadoop distributed file system. Map. Before I go with the actual practical part, right? Before I go with HDFS file system, I'll give you the knowledge on local file system. That is Linux system, right? I'll discuss the commands of Linux before I go with the practical. So from next week, mostly we go with the practical part. Local file system, that is Linux commands I discussed before I go with HDFS. Yes. MapReduce for processing in brief. Scoop for importing and exporting. Yarn, yet another resource negotiator. Yarn architecture, Yarn components. NoSQL like HBase. Hive, mostly with Hives. Hadoop Hive, right? Even we have jobs with Hive. We got good command on this. That's why I'll be spending more time on Hive. Hive tables, internal tables, external tables, partition tables, partitioning, static partitioning, dynamic partitioning, multi-column partitioning, bucketing, indexing, right? All this. And more discussion, more concentration on PySpark, very high speed technology. So RTD computations, persistence options, different persist options, PySpark core computing, fault tolerance model, grouping segregations, various actions transformations, PySpark SQL data frame, PySpark SQL functions, built-in functions, external sources, deployment modes, PySpark application stages, driver and executor, building Spark applications and pipelines, deployment modes, performance tuning, integration with Kafka. So here, how this PySpark integration with Kafka, PySpark ML machine learning and streaming. Apart from this, total in brief about Python also you'll be getting this knowledge, right? Python basics, Python operations, operators, IDEs, working with Anaconda distributions, Jupyter, Spider, Eclipse, flow control statements, looping statements, strings, collections, lists, tuples, sets, dictionaries, functions, modules in Python, packages, errors and exceptions, file handling, object-oriented programming, regular expressions, database access, database connectivity, Python datetime, operating system, OS module, advanced concepts like iterator, generator, closures, decorators, GUI programming, Excel workbook, analytics, introduction to data science, pandas module, numpy, and matplotlib, right? Okay. So this is what this yesterday I was discussing, right? Yes. So in this you'll be learning 4 things here: Hadoop, PySpark, Linux, and Python. Python Core and Advanced. This Python will be, you can attend any of my Python batch from Monday to Friday. It will be in the Monday to Friday. Means there are some batches going to start this Monday at 7 p.m. This Monday at 7 p.m. you will be having it, right? First 1 week it will be at 7 p.m. Later it will be at 8 p.m. after the end of this. And there is for morning batch from this Thursday, coming Thursday, right? There is a batch at 5 a.m. The first 1 week it will be, later it will be at 6 a.m., right? Hadoop, PySpark, and Linux, this will be in the weekend, Saturday and Sunday. Saturday 2 hours, Sunday 2 hours. So total 12 weekends. 15,000 is the fee structure for all this, right? You will be getting the session videos for all this Python, Hadoop, PySpark, Linux. Each and every session video, even if you miss any session, right? You can go through that video of it. Classroom of soft copy of the class notes. And a WhatsApp group will be created, right? And the interview questions will be provided, right? All the sessions will be interactive sessions, will be kept in unmuted status. You can ask queries at any point of time. And you will be responding for every statement I type, right? So from next week onwards, we'll be starting with the actual type.
So weekend class it is 7 to 9, right?
Yeah, it will be
Saturday,
from
7.
7 to 9. It will be
Okay, yeah.
7 to 9. And Python also, there is 7 to 9, 7 to 8 daily 1 hour. It will be weekdays. If you are able to attend for tomorrow, you can attend it. Otherwise, morning also available from this Thursday onwards. Right? Yes.
I'll prefer for morning once the time go with morning.
Okay. So yes, you can see in the chart, right? You can see in the chart the contact details of this online team. If you got any queries, you can just check with this online team. You can just copy that entire, so that you can see that post content link, yesterday demo video link, today's video also you'll be getting the tomorrow you will get a mail. In that mail you can see the video link of today's session also. But generally you will be getting the videos to your Google Drive once you got enrolled. Notes you will be getting clear notes. Yes. Yeah, you have got some the payment details and the process is provided, right? The contact details of the online team is provided. Payment details, everything. It's any other queries you have got, right? Yes. Yes. Fine. So from next week, we'll be starting with that. The software, everything I'll be providing to your Google Drive. A 5 GB software will be there that you need to download, and I'll demonstrate it, how to work on it. All the components of this you'll be for doing the practical part. Okay. So I'll stop for now. Next week we'll meet 7 o'clock same time, but the link will be changing, right? You will get a new link. For that, you need to get enrolled for getting the new link, right? The link will be forwarded 1 day before to your mail ID. You can check. If you have not received it, you can just call that number. And one more thing, if you got enrolled, don't forget to share the screenshot of your payment to that mail ID provided in that. You can see in the chart, there is a mail ID provided. To that mail ID, you need to forward the screenshot of your payment. Then only they'll forward you that link, right? Yes. Okay. Fine.
Hello.
Okay. Fine.
Hello.
Any other? Yes. Any query? Yes.
We'll be discussing that Parquet files and storing data in that and retrieving that.
Yes. Different types of files in Spark I'll be discussing.
Okay.
How to load different types of files, right?
Right.
ORC file, Parquet file, CSV files, JSON files, right?
Okay.
Different types of file formats, working with that, handling those. Any type of data it can handle. Fine. So if I'm done with your queries, if there are no other queries, I'll sign off for now. Meet you on next.
Hello, sir.
Yes, go ahead.
Good evening. Sir, will we get any mini projects means in this course?
At the last, I'll be showing you one flow, right? Just I'll show one flow. Project flow.
Okay. So means we can use that during our add that project in the resume kind of
Yes,
that.
yes.
Okay, okay, all right.
And sir, like, would we be using some cloud also here?
At the last in the Spark, I'll be showing you how we can also execute those things on the cloud environment. Okay, this everything whatever I'm discussing on premises, right? On premises by taking this cluster, we're just designing a cluster, right? On premises, but also I'll provide you the knowledge at the last how to run these things on the cloud side also. Databricks environment. Okay, fine. I also deal with Azure data engineering, how to work with it. There is a new batch also for that Azure data engineering tomorrow, Monday at 5 o'clock in the evening. There is a new batch for that Azure data engineering. Okay, but here everything I'll be discussing about this PySpark, Hadoop, Python, right? But as you asked at the last, I'll also show you how to run in the cloud side also. Right? Fine. Okay. So we'll continue next Saturday, right? At 7 o'clock, more discussion.